All right, so socket.io. Thanks for coming, everybody. To start, I wanted to introduce, I threw together a little program, a little app. It's live if anybody wants to go and connect. We'll leave that up for a moment and then I'll put it myself. And it's up there at the top if you didn't get it. And there we are. So a simple app allows us to do some chat. Over on the left here, we have room selection. So you can pick different rooms to be in. If you're in room 0, you can't actually talk to anybody. There we go. Chat. So I built the whole thing to just kind of demonstrate a few of the different functionalities that socket.io provides. And so yes, the Kanye button, that is the broadcast to everybody. Can't get away from that. We've got private messages. If you click on the bubble, hey Luke. So yeah, nothing crazy or amazing, just a simple little app to demonstrate sockets. So now, had I wanted to do this with HTTP, I would have had to set it up where the clients are constantly pulling the server to check if there are any new messages. So, how often is appropriate? 5 seconds, 10 seconds, 2 seconds? That incurs a lot of overhead, a lot of extra bandwidth that you're eating doing that sort of thing. And it also creates a situation where you have to have a stable server that's keeping running track of all the messages. With sockets, you can have it where the server can be pushing messages back out to various clients. As you can see, the arrows go both ways. So client and server can communicate to each other, but the clients only connect to the server, not to other clients. So why sockets? You can push from the server. You can have real-time updating. Think of like browser-based web games, multiplayer stuff, news apps, sports, anything like that where anytime data is generated, you can instantly push it out. It's got low overhead. Socket is relatively fast, and the packets that it sends are pretty small. It's easy to set up and use. I will go through and show the setup on this, and with relatively few lines of code, you can be communicating. So as I said, Socket's fast. The initial handshake is a little bit expensive because you have to establish a connection. Once that connection is formed, though, it stays open. And so once you get any sort of number of requests, as you can see, it becomes much, much faster than using standard HTTP. Size is also much smaller as well. And so you can save on bandwidth if you're talking about millions of requests. You can do anything with sockets that you can with Ajax. When I first learned about REST, I learned about it in terms of writing all the different specific routes for delete and get and post and all that sort of stuff. Essentially, you can do the same exact stuff with sockets, and you can use the two side by side in the same app. So Socket uses an event-based architecture, and on the server side, the main event is the connection. So as we see up here, we've got the I/O on. connection. So socket is each client that connects. And inside this function block, we then go ahead and define all the event handlers with the socket on. So each of these sockets represents like the client, and so one of the things that you get with this is you can say socket ID and grab the ID off of that for each individual client. And so here is one of those event definitions. We've got the socket on. Each socket has, or each event has an event name. You can pass in any number of arguments that you want. And then inside the function, you can do stuff. And there's always a chance to respond back, either to the client that called it or any number of other clients that are connected.
How do you designate which client you're sending the emitting the response to?
We will get that.
Okay.
Yeah,
Sorry.
we'll get to that. Yeah, that's part of it. Okay, so emit. This is our mainstay of our communication. From the client side, this is going to be the only event that we're going to be using, socket.emit. And so each event is going to be a unique thing. You can pass in any number of arguments with it. And if you want, you can also pass in an optional acknowledgement. So if you need a callback, if you need to like verify that something was sent and received, you can do that as well. And on the server side, you also have the socket emit. And so socket emit on the server side is always going to be going back directly to the client that made the call. We've got namespaces and rooms. So namespace for your socket is, think of it as like a walled garden. Like if you had an app that had a bunch of different places where you were communicating and you didn't want them, users, to be able to talk to each other, you can set up separate namespaces. Namespaces are set on connection and you can't change them. Rooms, however, can be changed. So like we saw in the app, we had 3 different rooms where you could click the button, jump in and out of rooms. You can programmatically, on the server side, change rooms. There are some reserved words that you can't use for your custom events. I'm just going to gloss over that though. I'll look those up at your leisure. Okay, so setting this up. For this app, I used an Express server, and just one package makes the socket possible. Make an app, use the HTTP module to make a server, bring in socket. Now, if you only want to have your server listening for sockets, then you use IO-listen. If you want to be able to use both AJAX and sockets, then you attach the IO to your server. That way you can use HTTP and sockets simultaneously. After that, you set up a module. In here you can see we've got the connection. So on connection, we then go in and define all of our event handlers. Anything you place outside of the event handler simply gets run anytime a client connects. And then you had asked about how to send to different clients. So we'll see a couple of the different emit functions here. So we've got the socket emit, where we're sending back the list of users just to the socket that made the call. And then we've got socket broadcast. If you chain that on there, that sends to everybody in the namespace except for the calling client. So if you pair the two together, then you get a broadcast out to everybody. Down here at the bottom, we're defining one of our event handlers. message. So this was where you type in and you hit submit. On the client side, it emits a message and gets handled here in the socket on. And so we grab the ID off of socket, that was who called, and then we can go into the users module, grab the user off of there, get the room that the user was in, and then we use IO in to broadcast and emit to everybody in that room, and then we emit a new message back. So on the client side, this is using React, Redux, and then I also used Thunk for this. So used Socket.io and Thunk. And so with Thunk, got to set up your Thunk by adding it as middleware in your store. And this here is the socket module on the React side. So you bring in the store, you bring in all your actions, bring in the client and instantiate it with the URL to your server. And then just like on the server, you can define your event handlers. The difference here is instead of emitting back, we are using dispatch. We're using Redux and Thunk to have the store dispatch an action. So then if you look at the actions file, that action that was just dispatched then returns through Redux to your reducers the object with the type and payload. And so if we were to follow the whole thing through, when you click on that initial submit, we have an action that gets called with the message, and here's where Thunk comes in. So instead of returning an object with type and payload, it's calling an action, which is the socket init. That then goes off to the server, which we saw in the file before, comes back through here and gets dispatched to this action. And so by doing this, you can take care of all those asynchronous actions. It doesn't really matter when something returns because you're using actions and you're having the store call the second action when the socket server sends the response back. And so then, list of different types of emits. Have the basic one, the emit to all clients except sender. You can do socket 2 to emit to just one specific room or multiple rooms. Can emit to everybody in a room, including the sender, everybody in a namespace, and individual messages like a private message. And yeah, that's about it. If anybody has any questions, I can dive into anything deeper.
What's a realistic number of concurrent sockets you can run? Like, I mean, I realize it's based off of the server you're running.
Man, I have no idea. I haven't heard of there being any sort of
Yeah.
So is the primary use for like chat and messaging and stuff, or what else?
Yeah, anything you want real-time updates for, anything you want to push from the server. But it'd be super easy with sockets, like if you had, if you had any sort of commerce app and you wanted to be able to have live chatting with an agent, you can simply attach that on and, with a few components, a few modules, have it up and running.
Can you show us through that code path that you mentioned? You said you could follow this from sort of like a click to the.
Yeah, so I can get in and show all the way. So we've got our chat. So here we go. You click on that button to submit. That calls the action post new message, which is up here in our action file. Is that too small? That's probably better. Okay. So the post new message, it's called. The message here, that's the string. We're using thunk to call socket emit message. That comes down here to the server. And so on message, we're going to go to our users module, get the user from the ID off of that call. And if we have a valid user, then we emit, we find the room that that user's in, and do an IO in to emit to that room, to everybody in that room, that message that came in. So then that comes back to the app side, comes into the socket module, and gets handled with the new message handler. So the store then dispatches the action, add chat message to list, which is back up here in our actions. Takes that message and dispatches an object with new message and payload down to the reducer, which is here, and appends it to the list.
Sweet.
Can you go back to your actions, the post new message?
Yeah.
So the socket emit method, does that return a promise, or do you have
Nope.
to put but you can't add a callback at the end of it?
You wouldn't.
How would you know if there's an error when you emit?
That's a good question.
Because you said you could do you can emit your event arguments, and then there was the final parameter, which was I thought that was a callback.
Acknowledgement callback.
What was that?
Yes, you can.
Acknowledgement, right?
There is the acknowledgements.
Would that carry the error if there was one?
I'm not sure. I actually haven't gotten that far into it.
Okay.
I haven't needed to
Worry
get
about
into
it.
that deep of a level of. And so the on error, one of those reserved keywords that I was showing, that would be what you'd use on the server side, where you can define, hey, if there's an error in this, then do something.
But the server side error is the general error for any socket that produces an error, right?
Yeah, I actually didn't check to see if socket on error is something that works on the client side as well. It might.
It may be that that IO object that you instantiated at the beginning, because it establishes a connection and then maintains the connection open, it probably has some error detection to detect that I'm sure you're.
Yeah.
It looks like it's got a couple of hidden events in there.
Right.
Like I'm seeing
If it
disconnect.
just doesn't respond with your packet, though, or like the response that you're expecting.
Yeah, well, and I think what I'm interested in is if there is an error on that specific call, being able to alert the user as opposed to, because you're using a thunk, what I would expect is the promise to not resolve, and then,
Well, thunk doesn't necessarily mean that you have to be using promises with it.
right,
Thunk simply means that you can dispatch a function.
right,
And so as we saw, like, there wasn't anything, it was just a socket. There wasn't,
right.
it wasn't a promise. My understanding though is that, that socket IO does have error handling, because they have, one of the options that you can use is volatile messages. And so if you add the volatile tag onto emit, you're saying, oh, well, if this doesn't get through, don't worry about it.
Oh, okay,
And so that makes me think that, you know, oh, if there is a problem sending something to the server, it's going to try again.
I just looked in the source code. They definitely have a on error method and a couple others.
Yeah.
And because it seems like, I'm not sure, but it seems like in that funk where you were calling socket.emit this thing, that seems synchronous, right? So it could be that you could just wrap line 33 in a try catch. I think that's what the JavaScript there, try catch. It may just straight up throw an error, right? As opposed to like rejecting a promise or something.
well, but I think that the socket emit is gonna be run synchronously, and you're not gonna get an error immediately because it's gonna do its async stuff in the background.
Well, I think that's the thing though, is I don't know, I'm speculating, so.
Oh, sure,
Yeah.
We're all speculating at this point.
Yeah, well, the reason,
Yeah.
what I was showing before is that it's kind of asynchronous in nature because I'm emitting the message here, but then the response comes back down here with the new message.
Right.
They aren't
And
really
it's-
paired. It's not like an AJAX call where I make a request and I get a response and then I can do something with that response.
Right, yeah, well, maybe I said Ajax, I meant asynchronous, because it
Yeah.
still has to communicate with the server, there's like some sort of delay in there.
Yeah.
So I was just wondering how to detect if that action failed, that's all.
My suspicion is that that line 33 happens all synchronously, and by the time you get to line 34, the connection has
Already
been
established.
sent and everything, right? Like, that's just my guess. I don't know where I get that from, to be honest.
Cool. Any other questions?
Yes. When you started, you were differentiating between sockets and HTTP, which then made me think about HTTPS. Am I right to assume that if you have an HTTPS connection, then the sockets are going to travel over that securely?
So when you first make that connection, it is actually an HTTP call, and then it will upgrade itself to a WebSocket connection if it can, but otherwise it communicates over HTTP.
Okay.
And I can only assume that if you make that connection over a secure, that it will continue that.
Gotcha.
Are WebSocket connections themselves secure?
I think there's a protocol, it's like WSS maybe, and that is like a encrypted WebSocket.
But there's no reason why you couldn't encrypt anything you sent over this.
Everything is actually encrypted. The documentation that I saw, up to the first call, as you said, it will be encrypted. It advertises as a quite secure application, so we will
Okay.
assume so.
All right, well, thank you.
That's good.